Let's get started with chapter one. This will be the lecture related to the chapter one lecture quiz. And really, this is just an overview of statistics and the basic concepts of conducting research in social behavioral sciences. So when we think of the term statistics, as you could see on the PowerPoints, it is ways that we summarize or interpret observations of samples. So it's a mathematical procedure. You've probably been exposed to statistics already. So, for example, if you watch football, the NFL football, if you ever have heard them report, the average um, yards per game. That average is a statistic. It is a value that is kind of summarizing something about the NFL or football. So, is what statistics does is it reports values or reports or summarizes um, kind of observations of data. And data are numbers that have been assigned to certain observations. They could be Data can also be considered scores or raw scores. And is what it does is it allows us to quantify observations. So if I'm observing something out in the real world, I'm going to put a number to that. And once I get, you know, one number for one observation, that is a raw score. But then all of a sudden I start combining multiple observations, multiple scores, and that is usually what we consider a data set. Um, and it allows us to kind of interpret those results using a quantitative method, meaning we can apply a number value to that to make sense of things. So let's go into a little bit further detail. So we're going to look at two different forms of statistics. We have descriptive statistics and we have inferential statistics. At the beginning of this semester, you're going to be focusing on descriptive statistics mainly. So descriptive statistics are exactly how it sounds. These are mathematical procedures or procedures, just mathematical, but procedures that helps us to quantify observations or behaviors. And it summarizes data, it describes data, it organizes data, and it's all often in the form of single values, which would be a statistic that describes a data set, or it could be with tables or graphs to kind of summarize or organize the information. After we get past descriptive statistics, which is the beginning of the semester, we're going to kind of use descriptive statistics and then go into inferential statistics. And this is where we actually test hypotheses. And we can typically take a sample that is taken from the population, and we'll talk about that more. And we'll test something about uh, this group that we're interested in, and it allows researchers to infer about the population parameters. Basically, we can infer that this sample, what we see in the sample, we would see this in the larger population. And we'll talk about the difference between populations and samples as well. But this is where we can actually start inferring things about the general population and testing hypotheses. So let's look at how we do this. So first of all, we typically have kind of this population of interest, this entire group of individuals that we have some research question about. And so it might be something like we're interested in aggression levels with adolescent boys. Well, it doesn't makes it's not possible for me to collect data on every adolescent boy out there. But the population of interest is adolescent boys, all the adolescent boys. So sometimes we do have information about populations. And if we have a value that describes that population, it's called a parameter. For example, if you've taken Psych 101, you probably have heard of intelligence tests, and specifically the Stanford Binet intelligence test. The average IQ in the population is 100. That is a parameter because that's a value that describes an average or also what is called a mean for the population. Now, often we can't test and test hypotheses on entire populations. It's very difficult. So, what we have to do is we have to utilize a sample. A sample is a subset of individuals selected from that population. So, a sample is a smaller group of individuals selected from the larger population that they are supposed to represent that population. And is what we do when we have a value that describes the sample, that's called a statistic. So whenever we're talking about statistics, we're describing, we have values that are describing a sample of individuals, whereas a parameter is a value that describes the entire population. So kind of we're going to be using those terms interchangeably. And we need to be start kind of being aware that with each term, they have different meanings and sometimes very similar meanings, but they often have different kind of definitions, different functions, and they often have what are known as different notations or symbols that describe those. And we'll talk about that a little bit more. So let's look at kind of how we conduct research. In social behavioral sciences, we apply the scientific method just as other scientific fields do. So it involves very specific questions and then finding systematic ways to answer those questions. And typically, this question leads to a theory. An overall question kind of leads to a theory, which is a general explanation of some phenomenon. So it could be, you know what, I think adolescent boys have higher rates of aggression levels, maybe than girls. That's what you think. And this general. You don't have actual research showing that yet, but this is a theory. So is what you need to do then is take that theory, that general explanation, and then you need to create a hypothesis. Now, a hypothesis is not a question. It is a testable prediction for the outcome of a research study. So in that case, maybe my hypothesis would be adolescent boys have higher levels of aggression than adolescent females. And that is something that can be tested using the scientific method. Now, there's lots of research out there related to this, and there's lots of possible explanations for that. But that's just an example of a hypothesis. Again, a hypothesis is not a question, it's a testable prediction. And so let's talk about how we conduct research in social behavioral sciences, very specifically the types of research methods. So probably the most common research method is the correlational method. So when we use the correlational method, we have two variables that are often used to determine whether there's a relationship between them. And the two variables are often each, person is measured on two different variables. So is what we do is we look at, so is there a relationship between the two variables? And is it a strong relationship? And what is the direction of that relationship? Meaning, as if one variable goes up, does the other variable go up? And as you can see in this graph here, we're looking at frequency of Facebook use and self-esteem. Now, on that horizontal axis, that bottom is the x-axis, and that's kind of this predictor variable. We're predicting that as the frequency of Facebook use increases, something is going to happen to the y-axis, which is that vertical axis, which is self-esteem. That those values are going to change depending upon the frequency of Facebook use. So you have your X variable and your Y variable. Those are the two variables. And we can use this for prediction. So in this case, as you can see, as the frequency of Facebook use goes up, self-esteem is decreasing. So that's an inverse relationship. And because those dots on that scatter plot are pretty close together in a straight line, it looks like it's a pretty moderate to strong relationship. But we don't have any values or statistics to be able to state that. But that's really what a correlation the correlation method does, is it looks at the relationship between things. We have to be very, very careful because correlational research cannot state cause and effect. We cannot state that using Facebook causes a decrease in self-esteem because there's lots of things out there that could be related to self-esteem. So, yes, there could be a relationship between Facebook use and self-esteem, but we're not controlling for all the other possible things that are impacting self-esteem. Could be age, it could be um, ex personal experiences, it could be personality, it could be a lot of different things that's influencing it. So all we can do is say a relationship. We can never ever state cause and effect when we're talking about correlation research. But this is by far the most common research used in social behavioral sciences because um, humans are very hard to control. In fact, almost impossible to control. So we can never state cause and effect, and often we have to look for at variables that are already there, things that are already there happening in the world, like things like violent television and violence. As violent television increases, violence increases. Now, we've probably heard many, many, many times that violent television causes violence. We can't state that. In fact, that is incorrect for that to be stated that way. We can only say that there is a relationship and maybe there's a strong relationship. And has been a strong relationship shown that as the number of hours of violent media, violent, those types of things increases, violence tends to increase within society. But we cannot state cause and effect because we're not ruling out all the other things that could be influencing violence. So be very careful that you're sure that cause and effect can never be stated with correlational research. So experimental research, on the other hand, can state cause and effect. So this is the only type of research that can actually state cause and effect relationships between variables. And a variable, when we talk about a variable, it's usually a condition that changes for different individuals. So aggression, my aggression levels are going to be different than your aggression levels, and your aggression levels are going to be different than your classmates' aggression levels. So a variable is that condition or a characteristic that changes. And so to conduct an experimental method, there are specific requirements that have to be met for us to be able to state cause and effect. A true experimental method will be able to state cause and effect because it meets the certain criteria. First of all, there is an independent variable that is manipulated. So manipulation of the independent variable. The independent variable is typically what we'd call the grouping variable. So um, let's think about a common um, thing that is looked at as like a medication, a new medication. So that would be fall under like treatment, right? That would be your independent variable, treatment. But you're not going to give everyone the new medication. You're going to you're going to split it into groups or conditions, and the researcher is going to manipulate what those conditions are. One of the conditions is likely going to be the new medication, and the other condition is going to be a placebo or what is called a control group. The control group is typically um, like the group that is not provided the new treatment or a treatment. It is kind of this like without new new exposure to things. So the independent variable is kind of an umbrella term. So I would say if I was looking at let, let, let me rewind real quick. I'll get back to that. Um, we have both an independent variable and a dependent variable. The independent variable, I always think of it as the grouping variable. The dependent variable is the outcome. So let's say we were looking at um, a new antidepressant, and an antidepressant treats depression. So your independent variable is the treatment, and the dependent variable would be the depression symptoms. Excuse me, I have a tickle in my throat. So the treatment symptoms is the dependent variable. Now, the dependent variable is going to depend upon the independent variable or which group you are in the independent variable. So you're going to have your experimental group, which is the new antidepressant, and that's one group of the independent variable. And then you're going to have your control group, which is a placebo, more than likely. A placebo is typically a sugar pill. So people think they might be getting treatment, but they aren't, so that we can really see, is the new antidepressant really working? So those two groups are part of the independent variable. The dependent variable would be the outcome, which would be the symptoms of depression or depression levels. Now, the dependent variable has to be quantified in some way or measured in a certain way. And that is what we call an operational definition, how we measure things. So let's look at um, how would we measure anxiety if we were operationally defining it? There's lots of different ways we could measure anxiety, lots of different ways we could measure depression. We could measure depression by giving an assessment, a survey. We could measure depression by asking just like having a conversation and kind of listing symptoms and how many symptoms of depression there are. So there's lots of different ways, but is what you have to do is you have to turn the that observation into a value that's quantifiable, meaning there's quantity attached to it, there's numbers attached to it. So the dependent variable has to be operationally defined, and we'll talk more about operational definitions. So the manipulation of the independent variable is very important. There has to be control. That means the researcher has control of how that independent variable is manipulated, and the researcher can randomly assign individuals because there is control. So meaning every person within those groups, whether it be the experimental group or the treatment group or the control group, every person has equal opportunity to be in either one of those groups. So the researcher can randomly assign people and has control over the independent variable and the manipulation of that. The only time we can state cause and effect is if all of these requirements are met, um, and systematically met. We cannot state cause and effect otherwise. So let's take a look at this a little bit further. So as you can see, we have two groups here. So we have, and as you can see, it explains the independent variable. It's the variable manipulated to create two conditions in this case. The experimental condition is the humorous video, and the control condition is the action adventure video. So for some reason, maybe they think, you know, humorous video, it uh, increases or some outcome variable. It doesn't even matter what that outcome variable is, because is what you need to see is that both of these groups, both of these conditions are measured um, on the same thing. So whatever that outcome is. So let's say maybe these are happiness levels. Let's say happiness levels. Do your levels of happiness increase when you watch a humorous video compared to a standard action adventure movie video? Um, Maybe that's what we're looking at. And that would be the dependent variable, is that happiness level. And so that's measured for both. That's the outcome, the dependent variable. So you could see there's scores below that. Like we are quantifying some condition of those observations. So if we were to look, if I was to ask you, okay, what is the independent variable in this? You might just say video exposure, because it's not, the humorous video isn't the independent variable. The humorous video is the experimental condition. And the action adventure video is not the independent variable, it's the control condition. Those two components together make up that independent variable. Helpful thing that I always said was to remember the difference between dependent variable and independent variable is I always think the dependent variable depends upon the condition for the independent variable. So it depends on the independent variable. Hopefully that'll help you a little bit. So another method, research method, is the quasi-experimental method. It is very similar to the experimental method, but the researcher lacks control. And that means the researcher cannot control or randomly assign people. So it's typically when we say quasi-experimental method, it's because there's a quasi-independent variable. And that means that that independent variable is quasi, meaning the conditions or the groups that differentiate those conditions are the result of some pre-existing condition or an inherent condition that the researcher has no control of. And because there's a lack of control, we cannot state cause and effect. So in this case, you can see there's men and there's women. The researcher can't control what chromosomes you're born with. And we're talking about sex rather than gender. So men and women, when we're related to sex, we have to use the term gender, but to be completely biologically scientific, let's refer to that as sex. So I have no control over whether you have an XX chromosome or XY chromosome. And as a researcher, because I don't have any control of that, I can't randomly assign. Women don't have an equal chance to be in either the men or the women. They don't have a chance of being in the men. So there's no control and there's no random assignment because there is no control. So that would be a quasi-independent variable, those two conditions. And again, the dependent variable is that outcome variable. We're measuring the same thing on those two conditions, but those conditions are not manipulated because there is no control over those. So that would be a quasi-experimental method using a quasi-independent variable. Over the course of the semester, you might hear the term independent variable used even when we're using quasi-independent research or quasi-experimental research. They often are used interchangeably, but we need to be very careful that we know that it's a quasi-experimental method rather than a true experimental method because we cannot state cause and effect because of that quasi-independent variable. So that is the third method, research method that we use. So let's talk about those operational definitions. So the definition of an operational definition is a measurement procedure for measuring an observable behavior or for quantifying an observable behavior. So is what you have to do is be able to make an observation and then apply a value or a number to it so that it can be quantified. Because we can't do math on words. We have to have some values that represent meaning. So think about how math anxiety could be operationally defined. I could just ask you, do you experience math anxiety? Yes or no? It's easy. Yes or no. And I could, for the word yes, that could be provided a number one, and no could be provided a zero. That's how I would quantify it. Um, I could ask on a scale of 0 to 5, how much math anxiety do you experience? 0 being meaning none, 5 being the most extreme math anxiety ever, and any number in between. So those are two like different ways to operationally define math anxiety. If you could see, there's another one. We could monitor physiological responses to math. So from some of you nursing students or in the health field, blood pressure increases. You could monitor blood pressure. Heart rate increases. The temperature at your fingertips decrease because the small blood vessels constrict. So the temperature at the fingertips and the toes decreases. That's another way to measure physiological response because as anxiety goes up, those temperature in your the fingertips and toes, those smaller vessels, they constrict and the temperature decreases. So that's another way of monitoring. So there's lots of different ways that we can quantify an observational behavior, and that is called an operational definition. So when I ask you, what is the operational definition for anxiety, you're not going to, you know, Wikipedia or Google, what is the definition of anxiety? You're going to tell me, how are you going to measure anxiety? That's what you're looking for. That is what I'm looking for, is that measurement. How will you measure this? So that we can compare people with each other or compare measurements with each other. So here's kind of different ways that we measure variables. Now, for the remaining portion of the semester, you're going to be revisiting what we call classifications of variables. Now, there's 4 different types of classifications, but for every variable, there's 2 classifications that you will use. You'll use either discrete versus continuous or qualitative versus quantitative. These are like 2 categories. So a discrete variable typically are indivisible categories, whole units. Um, it's typically either whole numbers or categories instead of like data with decimals and those types of things. So an example would be gender. It's either male or female or sex, but gender is often used interchangeably. And that's for a whole nother topic, but um, male or female, and those are just categories. So that would be a discrete variable. If I said the number of students in this statistics class, those are whole numbers because you can't be half a student. I don't have half a student. I don't have a quarter of a student or 3/4 of a student. These are whole numbers. So even the number of students in my statistics class is a discrete variable. Now, it's either a discrete variable or it could be a continuous variable. Now, a continuous variable is an infinite amount of possibilities that fall between any observed values. So that's usually where we're talking about there's decimals involved. There's definitely decimals or fractions of numbers involved. So a sprinter's time to finish a race or weight in pounds. You know, you ask me my weight in pounds, and I'm usually giving you a whole number. But in reality, there are fractions of a pound. And so that would be a continuous variable because the potential for decimals or fractions is there. It's not necessarily what you have, but it's the potential. So you would choose between one of those two, discrete or continuous. And then you'd have another classification, either qualitative or quantitative. So qualitative is usually just varying by class or by a label. So non-numerical observations. So again, gender would fall into the qualitative measurement classification. And maybe size of t-shirt, small, medium, or large. It seems like, well, large is bigger than small, but it's not precise. If you go and you get a large shirt at Target, that large shirt at Target might be very, very different than if you got a large shirt at Walmart. I mean, there is really large variations, or depending upon the brand of t-shirt, those types of things. So there's a subjective difference, but it's a quality difference over a quantity. You can't measure and go, it's exactly 2 inches difference between a small and a large, no matter what. It's not. So it's usually by class or label. Um, Quantitative variable, it varies by amount. So basically, it's measured in numbers. You can subtract the larger value from the small, or the smaller value from the larger value and find the difference. So number of students in statistics is an example of a quantitative variable. If I have 25 students in this class, but I have 23 students in my other class, that's 2 more students in this class. I can subtract the number of students and find a difference. So there is a quantitative difference. Same with weight in pounds. If I lose 5 pounds, then there is a quantity difference between those two. So When I ask for classifications of variables, you should always be giving me two. You should never just give me one. You should always be giving me two. So it will be either discrete or continuous as one of them, or and qualitative or quantitative as the second classification of variable. So those are kind of some of the overall classifications. Let's look at our scales of measurement, sometimes just referred to as measurement scales, but scales of measurements for variables. We have four different scales of measurements. So for every variable, you should give me two classifications and one scale of measurement. So let's describe what the scales of measurement are. The first one, the most simplistic is nominal. Nominal is just categories. They lack any value, even lacking a inferred value or a subjective value. So gender, male or female. You could say like political party. That could be an example. Um, could be one. It's just categories. So that's one scale of measurement. Ordinal, on the other hand, is categories, but they're usually in an order or a ranking, some subjective value. So again, if I was to ask you, what is your level of interest in this statistics class? And I give you the choices, low, medium, high. High is a higher level of interest than low, but we can't subtract low from high and get a quantitative difference. But there is a subjective value difference between them. So ordinal is ordered data, ordered categories. And the hardest ones to choose from are interval and ratio data. Really, the key to distinguishing between interval and ratio data is what does the zero mean? Or is there a zero? For interval data, it's can basically um, data that has a quantitative difference. So you could subtract the smaller from the higher and get a difference. But there is no zero, or zero is just a placeholder and not a represented score or a representable score. So, for example, on the Stanford Binet Intelligence Test, zero is a placeholder, but you can't score zero. It's not even part of the measurement. Zero isn't even part of the measurement. So, um, because it's not even part of the measurement, zero isn't is meaningless. It's a meaningless placeholder. So it's interval data. If you have 100 IQ versus 110 IQ, that's a 10-point difference. There is a quantitative difference, but there's no zero. Often when you see um, things like, you'll get assessments on like a 1 to 5. How satisfied are you on a scale of 1 to 5? One being the least satisfied, five being the most satisfied. There is no zero at all. So there would be, um, it would be in interval data. It could be on a 0 to 5 scale, but zero represents least satisfied. Well, zero doesn't represent complete absence of satisfaction. It just means least satisfaction. So zero, again, is just an arbitrary placeholder and not an actual, it doesn't actually mean an absence of anything. Whereas ratio, the variables, the measurements do contain a true 0 point, meaning zero means there's an absence of something or the measurement scale starts at zero. So, for example, height in inches. I know it's very difficult for some of you to wrap your head around the fact that, well, no one's 0 inches, but the ruler starts at zeros. It starts at zero, and there's a true measurement of zero. So any physiological measure is going to be ratio data. It starts at zero. If you get a zero on exam one, that's a true zero. It means you got an absence of a score. So um, be sure that you are kind of really thinking about, is there a zero? And if there is a zero, what does that zero mean? Does the zero mean an absence of something? If it means there's an absence of something, that's ratio data. So again, if I was to ask you, which you will be asked the entire semester for the classifications and measurement scale for a variable, you would give me two classifications and choose one measurement scale that would appropriately operationally define your variable. So to wrap this up, you're going to be doing hand calculations, a lot of hand calculations. I want you to be aware there's some things that um, you need to know about hand calculations. I think it says Appendix A has a mathematical review. It's actually Chapter 1 has a mathematical review. Um, but that order of operations, and I also have a video related to order of operations. And so we're going to be starting to use statistical notation quite a bit in over the semester, and you want to start memorizing these notations, which are symbols. So scores, raw scores, are often referred to as X or Y. You know, X and Y, often when we're using X and Y, it's when we're using correlational data. So scores are often represented by X or Y. A capital N is how many scores are in a population. And a lowercase n is the number of scores in a sample. This is important information because it'll start helping you get used to kind of comprehending the language of statistics so that you can start doing those calculations. So when you're calculating with statistics, there's some things that you're going to be exposed to. Um, a lot of our calculations will have procedures related to adding things up or taking the sum of a set of scores. And instead of saying add these, it uses the summation sign, which kind of looks like an E. That E, which is a Greek letter, it stands for summation or add. So whenever you have that summation symbol, it and it's followed by by a symbol or an equation, that just tells you what needs to be added. And remember, summation is always done after operations in parentheses, after squaring, multiplication, or division. It is the same as addition in that order of operations. So that summation has to be done just like any other order of operations. And summation is done before other addition or subtraction, depending upon um, the order of operations and what those notations are. So always go through kind of those order of operations. So anything in parentheses you do first, right out the gate. Anything exponents you do second. Okay. If there's no parentheses, then exponents go first, right? Then you multiply or divide from left to right, and then you do your addition. That's done next. So any of the other things are done first, and then any other addition or subtraction is done. So make sure that you are going by those order of operations, however you learned it. I learned, my dear Aunt Sally, you probably learned it as PEMDAS, but do some practice on that. There is an order of operations video that I recommend you watch because there is an order of operations activity. I hope this lecture was meaningful. The nice thing about having a recorded lecture is you can rewind and go back and review anything that you've missed. I hope that the rest of your semester is going very well.